right. What we're going to do here is we're going to talk about how to revolve, how to find volumes of solid when you have something that's revolving around an XY axis. All right, so here is an example that you might find. Okay, now when you talk about revolving, we talked about in our previous section is that we always find volumes of solids by using cross sections. Okay, cross sections, because everything, all volumes are by using cross sections. So volume using cross sections. All right, so we took the integral from A to B of our area of our cross section times dx. Now, when you're revolving something, let's just say we're revolving this around the x-axis. So we're going to take this small little part right here. I probably should make that a little bigger, but let's just say we have this small little thing and we're revolving this around the x-axis. So what's happening when you revolve this around the x-axis? Well, what you create is actually a solid with two different things, and you are going around that and you are creating, well, in this case, what's like a cone, because you have a triangle that's revolving around and creating a cone. Well, what's your cross section? Well, if you slice this up, you realize this cross section is a circle. So how do you find the volume when you're revolving something around an axis? You are actually using circles. Circles. The cross sections are circles. All right. So the cross sections, all right, when you revolve, are circles. Cross sections are circles. Now, so that means our area equation is pi r squared, pi r squared. Now, the question is, what is our r value? What's our r value? Well, our r value, and I'll get a different one right here, is going to be, well, the distance from our x rotation up to the function itself. So right here, this distance from here to here is what r is going to equal, because the whole length, that's the diameter. And so all we're talking about is this little section right there. So that length from here to here. All right. So if you can't see that very well, let me try to make this in green. Maybe that's going to be better. So from the axis of rotation to the function itself, that is what r is going to equal. So r is going to be from the axis of rotation. All right. So r is going to equal x rotation up to the function depending on what that is. So that's that distance. So in this case right here, here's our r, here's the function, here's our x rotation. And so we're going to take, in this case, upper minus lower, so f minus our axis. Okay, and that's what r is going to equal. You have to put it in terms of x. Now, what do you call this? Well, this is what's known as, in calculus, is using the disk method, because we're just using little circular disks. So from here, we're going to solve this by integrating. We have our limits of integration from, where is this going to intersect? Well, we're starting at 0. You can see right there at 0. And if we solve this right here, what is our value going to be? Well, if I make an equation of our line, we have y equals negative x divided by 2, and I got a plus 2 right there, divided by 2 is going to equal 1. And so where is that x-axis going to be? So if y is 0, that value is going to be at 2. So it's going to intersect right here at 2. Okay. So we got to come from 0 to 2. What's our x rotation? Well, the upper limit, this function actually is going to be negative x divided by 2 plus 1 minus our x rotation. Well, our x rotation is y equaling 0. So it's going to be at minus 0. All right. And we're going to take that radius, because that's our radius length. All right. And we're going to square it. We're going to put our pi in front, because we're using this as our equation, and dx. And that is what we have. So if I simplify this a little bit more, we'll have pi times the square root of 0 to 2 of the quantity negative x divided by 2 plus 1 squared dx. And that is how we get our value. So how do you find when you're rotating? Where cross sections are going to be circles, and we take pi times the integral from a to b of r of x, that quantity squared, dx, and that's where we get our value. All right. How do we find that? Well, really, that is going to be the distance from the function to the axis of rotation. That's how we find our R of X. Okay. Well, I hope this helps you out with finding this. We're going to go through some more problems on how to set these up and how to find them in our next videos. Maybe